I want to kind of re-hit what the purpose is of each step, because there are some problems where it seems ridiculous or silly to draw the picture, but I'm still going to grade if you do or not, because it's a process, it's a habit. But here's what happens. Here's the general idea behind each step, and there are more advanced statements I can make. But when we do R2D2 guess, when we read twice, what it really is doing is setting up the basic understanding of the problem, and then it's helping us set up our drawing. When we draw twice, the first drawing should tell the story, and the second part is labeling the drawing. It helps us unlock things that are not mentioned in the problem. Like, for example, on our, I think it was the potential energy homework, I asked, what's the acceleration if I drop an egg off a balcony? So what's the acceleration if I drop an egg off a balcony? What do you think? Drop it in chat. Let's talk about some secrets. Because I think we're at a point now, we say these things in the beginning, but you don't get it because you haven't gotten stuck. Okay, a lot of these will make sense because you've gotten stuck now. You've done enough problems where you're like, I don't know what to do. Okay. So when we read twice, the reading twice does two things. Okay. First, it helps us draw the story and tell the picture. But the other thing it does is it just tells us, well, what are we actually dealing with? It gives us the big picture. But it leads into drawing the picture. Now, when we draw the picture, the drawing actually unlocks things specifically that are not in the problem, like gravity. So in our potential energy homework, there was a question that said in the 7 steps, what is the acceleration if I drop an egg off a balcony? Well, if you had actually done the process of drawing the egg, falling off a balcony, some of you did this, you would go, oh, it's falling because of gravity, so there must be a g, which is negative 9.8. And you just finished the problem. That was the answer. And all you did was have to draw the picture. So that's part of the beauty of doing the 7 steps is you can actually approach a problem that you have no clue how to solve just by reading it. And if you do the steps like will uncover. It's almost like you're an archaeologist uncovering one little piece at a time. You're uncovering one little piece of the puzzle, and you're like, oh, and it allows you to see what the solution will be. Okay. And it's hard to see that and believe that because we start with problems that are simple where you are supposed to be able to read the question and almost know the answer immediately. Because I want you to not stress out about not knowing the answer. I want you to figure out the steps, okay? Because later, I don't know what the answer or how to solve this, but I'm going to do my steps and, oh, that's what it is. Okay, I got this, okay? All righty. Then we make a given chart where we list all of our givens. Basically, we're making a list of everything in one spot. Because it's all in one spot, because our drawings can actually get crazy and things are in different places and it's not easy to see sometimes. But because it's all in one spot, it can actually help us see the equation before we even start looking for it. It's also something we haven't done in this class, but it's also where I check for units. So if I tell you that we're going to drop something from a 32-foot high tower, in physics, you would have to convert that to meters. And in your given chart, you would go, oh, that's not in meters. I have to change it to meters. And you would do your conversion, okay? We just haven't done it because that's beyond what we're ready for, okay? But that's what you could do. Then you make the unknown. Now, the importance of the unknown is it actually clarifies which unknown you're looking for. Because like at this egg problem, I could be looking for you. I could be looking for the velocity before the egg hits the ground. But it's actually asking for the acceleration in that particular problem. So writing the unknown clarifies what are we actually looking for. And it's pretty important to know what that is, especially this week when we may have to write two equations to solve our problem. We may have two unknowns we have to use. Okay. Now, this is where most of us got this part. We've got this top part. Most of us are doing pretty good with this. There's only a handful of you that are having trouble with this top part. Most of us, it's when we get to the equation where things just fall apart for us. Okay. So let's talk about the equation part. You should choose the base equation before you do any algebra, do any triangles, or use any other helping methods, and you should write that equation down. So if you're doing work, doing a 7-step problem, and this is the equation, well, then that's the equation you should write. Now, some of you were writing the derivative equation of that to solve for a problem, but I don't know how you got to that. And so it makes me wonder if you know what you're doing. Okay, so you have to write the base equation before you do any algebra to the equation. And I will show you the triangle method in a second. For those of you that are doing that, you know what you're doing. Okay. But one reason why I want you to write the base equation is especially in this unit, you should recognize it for what it is. U equals mgh. Well, that's potential energy. That base equation not only is connected to the unknowns and givens table, but it also reminds you of, yeah, that's what I'm talking about. That's what I'm doing. Okay. Now, substitution. So the equation is where probably the number one mistake some people are making. The second mistake is substitution. I personally prefer that you substitute first before you do any changes to the equation. I prefer that you actually plug in the numbers before you do the algebra, because now I can see what algebra actually needs to be done. Now, with that said, what a lot of us are doing, those of you that are missing this really big time, is whatever the equation is, you're not reading the container. So like in your homework, this was 20 watts, and you were just putting it in here for the W, and you were just plugging in numbers and getting random numbers. And that would be the wrong answer, because 20 watts is not work, it is power. And so it goes in this container. Okay. So we're applying a bunch of things all at once to be able to do this. But when you substitute, you got to actually read the equation and plug in things in the right spot. Okay. Last thing, solving. You probably noticed in your comments, if you've read those, that I'm being a stickler for showing all your steps of your work. Okay. Because we're actually having to do algebra, and we're actually having to do a lot more math now in our 7-step problems, I need to see your work. Partly because you need to see your work, because the harder the physics gets, guess what? We all are going to go down the wrong path and make mistakes. That's part of the problem-solving process. However, it's a lot easier if you've shown all your work to go down to step 3 and make one small change and change a negative here, and then change all the signs, because you've already got all the work done. But some of you like did corrections on your homework after I showed you how to do it, and you did it in a different color. And because you were showing your work, it was easy. And those of you that didn't, you just had to start over and do it all over. Who wants to start over? So if you show all your work, it helps you spot what the mistake actually was. It helps you make corrections quickly. It will actually save you time. Usually, what is the time involved in showing all your work? It is the time it takes to write it down. Because many of you, you're doing the steps in your head, you're just not writing it down. Okay? However, when you make a choice to make a wrong step with your algebra, because you don't write it down, you can't see that that you made a mistake. Also, For those of you that don't show your work, it takes me about twice as long to grade because I can look and go, yep, that's correct. 40 points out of 40. Whereas, oh, there's a step missing. Okay. No, you missed the algebra here. Okay. And now I have to stop and think and do a lot more work. So the more work you show, the faster it goes for me as well. And I promise you, it generally only takes you about 30 seconds more to actually write out the steps because all it is you just writing what's in your brain. Okay,